ever have an idea to make plastic parts? You have many methods to make plastic parts, but today we're going to take a look at some injection molding. They could be different colors, different textures, different shapes. Here you have a sort of carbon fiber look, but if you look close, it's actually glass fiber or different additives that they can add to the plastic that actually make the plastic more durable or softer, or maybe over here, different material like polycarbonate material like PC. That is like what my glasses are here. That will allow light to shine through. Every different plastic piece has a different story behind it. Or in this room, we're taking a look at mold design. Basically, you need to design a mold in the 3D CAD software, computer-aided design software. And that basically takes humans that act to design the mold around the actual part itself. So you have the part, but then you also have to design a mold. And molds have to be designed. It's kind of like a black magic of how they get made. There's a whole art and science here. You see a mold core. So the way the plastic melts, the different materials melt at different temperatures, and the material goes into the cavity. Sometimes it's multiple cavities or holes inside the mold core. Those can be made out of different metals as well. So you have hardened steel, you have soft steel, you have sometimes aluminum, but that's not very common. And that's what these folks are doing over here. They're designing the actual injection mold cores that go into the mold base. They are basically cutting steel in these rooms, and they're using this machine to spin really fast. It's called a CNC machine, or computer numeric control. And in this, they are actually spinning an end mill, which basically will go and cut the different sides and edges of the steel so that it's hollowed out. It's basically subtractive manufacturing where it cuts away the material. So they have these vending machines for the end mill. They can come over here and the operators can identify which tool they want. They can check out, and whoever sells the tools to them will be notified, and then they'll basically be billed monthly. This is a vending machine for buying tooling, so you don't have to go to the store. They have them stocked here, and it makes it extremely convenient for the team when they need a certain tool. They don't have to go and wait, days or weeks or hours. They're able to get the tool when they need it immediately. This is the staging area for the injection molding components. They're being set here with the traveler and the work document so that each item has its own document that you know what is being manufactured. For the employees, they can pass it from one employee to the next and they know what's been done. They have barcode, they have scanners, they have checklists. So every component can make sure that it goes through all of the steps. This machine is a 5-axis CNC machine. And you'll see that it can go in multiple different directions to cut out material. Over here is the 3-axis, and what you see is this liquid being shot out. It looks like milk, but it's actually a lubricant being shot out into the end mill because of the heat that gets transferred from the end mill to the actual metal part. It heats up, and so they need to make sure that that doesn't bind and have friction and break. This robot arm will come in, and this wall is staged with different components that need to be cut out. The robot arm will automatically pick up the different components. It's copper, and it will manually place it into the side of the CNC here. It can run, and then automatically it will take it out. It'll put it back on the rack, and it'll put the next piece in place. So it's more or less automated without people. When you take a look at these machines, you'll see that they're very big. Over here's a nice view of a multi-axis machine. Some of these machines, they cut very precise. Other machines are more of a rough cut, more of a bigger cut. There really is no way to rush these machines. They cut steel at a certain speed. They can't go super fast. They have to maintain a constant speed because if they try to go fast, the tools, the end mill, will break. This area is called an EDM, and I will do the best I can to explain it. Let's take a look at these components, and we'll come back there. Each one of these components is, these are copper, these ones are graphite, and they more or less do the same thing, but these pieces will be made in areas inside an injection mold that are hard to CNC or to cut away in the steel. They'll use these pieces, it's upside down, so they'll turn it, they'll put it inside this machine, and inside this machine, they're applying electricity. So electricity will flow through this copper and through the lubricant, and it'll touch the steel in the exact location that they want to cut the material from the injection mold. So these are coming down, and there's electricity being applied inside these. There's lubricant. That lubricant is very hot. That material is very hot, that oil. And it's allowing the electricity to conduct and touch the steel component, basically cutting away little by little, cutting away at the steel, creating a hole or a cavity
whatever the shape of that copper is. And copper is a good choice. It's a good conductor, and it doesn't have a lot of force. It's not pushing it. It's the electricity that cuts it. It's not the actual sheer force of it pushing back and forth, allowing it to actually cut little by little and cut away at that metal. In this room, they have EDM, so they have copper and graphite. As I walk in this room, it smells like a nail polish factory.
Yeah.
Because it's like pungent, going back and forth with the electricity, touching the component, and it's slowly in there just kind of zapping away, putting electricity to that component. The operator is lifting the bath, and the bath is slowly going up.
Oh, wow.
And submerging the workpiece, or submerging the piece underneath. See over here, but you can see the mechanisms in the wire cutting machine. Basically, they have wire on a spool. It goes around, comes through here, goes through, and it comes down. And they have fed this. It's probably difficult to see, but they have actually fed that wire through the lubricant. There's lubricant in here, and they're feeding it through the mold part, and they're cutting a little by little. So this is acting almost as a saw. As it comes up through here, it's cutting it just kind of one direction, and it is slowly cutting away at the steel component. So sometimes when you have to make holes, it's difficult for a CNC to get in there to make that hole, but you can see that they're putting a hole all the way through the mold, and that hole is being done with a wire. And here's the configuration for the wire and how it's running through here. So for a CNC to get all the way down inside those holes, it's probably not possible, but for a wire cutting machine, it is definitely possible. This is the grinding room. So they basically use these machines to cut the material back and forth. It's almost like a high polish, but not really, because it's using a mechanism to grind and cut away and make that part really fast. When you look at this, it actually is hardened material. So they put it through a process that makes that steel harder than normal steel. It's a hardening problem. The operator is grinding little by little pieces away, and it's very lightly touching it. And he's manually doing this. It's a manual blow. This room is basically used to make sharp corners, nice flat edges, so that when this piece goes to touch another piece, it fits just perfectly. I can hear polishing. So let's go take a look. Basically, polishing is where they'll polish a mold, they'll put a lubricant on it, and they'll polish a mold, maybe making it really shiny or glossy, so that clear parts like a lens to a headlight can be see-through. And probably the heart of the process is the quality control. So part of this quality control is making sure that the parts that they design and manufacture what they should be. The tolerances need to be checked. So they have a lot of different machines here. Over here you have different machines, and all the machines do different functions. We'll start over here. They will use this system here. This table will turn, and they'll basically be able to take a camera, and with all the dots, they'll be able to identify and scan the different components. Basically, this department is making sure that the parts are being manufactured to the design specification from the customer. This machine here is testing the surface texture. So when you take a look, you can see the measurements for the surface texture, and it looks like they're following ISO 1997. This is a type of video measuring machine where the operator is manually moving with a joystick, manually moving the camera and establishing the different connections that you need that makes with the 3D CAD file that they are comparing the components. He's checking the different sizes and programming the machine to inspect it for him using a camera. And again, this machine is also calibrated, where the inspector comes in once a year and calibrates to make sure that this machine is within specification. From the distance, you can see that probe is coming down. That's called a CMM machine. I don't know if you're going to be able to see it, but it's pushing a probe and touching different points of the metal. And it's actually doing a type of point cloud where it can evaluate how the design was made and how close it is to how it should be made. Through here, this is where they are storing they're fitting the injectables together, and metal going into metal has a very tight tolerance, so they'll hit it. You see these overhead frames here that are used to pick up the molds. These molds are very heavy. There's no way that they could pick it up by hand, so they use these overhead gantries to pick up the steel, and then they place it on a part. They'll push the parts around the factory to another There are various tools that are used in this shop. I'll point some out. Over here is a laser, and they'll use the laser to etch the names into the mold. Over here, we have a really big machine that will fit the mold pieces together, because the mold pieces, you can't put them by hand very easily. You can't hammer them. They're too big. So this machine will force them together. There are many different parts to an injection mold, but these are the ejector pins. Ejector pins are used to push the plastic out of the mold or out of the cavity after the plastic. People wonder why injection molds are so expensive or take a long time. It's because they're extremely complex. We'll walk through the different processes of how to manufacture a mold. You see, some of these molds are very big. The mold itself is only half the battle. Once you get the mold, you have to put it into an injection molding press. That press takes plastic. We'll take a look at it a little bit later, but it will melt the plastic pellets, pushes it through a screw with a screw, and it'll push it into the molds themselves. But you can see some of them are really big. These right here, these are the connections for a hot runner. A hot runner is basically a system that allows the plastic to heat up and cool down, and it keeps it near the nozzle. So it basically doesn't waste plastic, and it's a way for them to prevent wasting extra plastic. When you're making millions of pieces, you don't want to waste plastic. We'll take a look at a little bit later how they make some of these pieces, but these two pieces come together in the mold core. This green stuff that you see here is a lubricant, so it allows it to last in humid environments. You don't have to worry about the material changing color or degrading while it's waiting to be produced. But these definitely look like some sort of headlamp or a light to a vehicle. Once the injection molds are fully built and made, they go and they get put into these injection molding presses. So the plastic pellets are sucked in through the hopper. It then goes down into this big, huge tube, which has a screw on it. And the screw will spin. It will push the material through this heater. And this basically is a big band of heat. From here, the material gets pushed through, and it slowly goes into the cavity. So this is a really large injection mold. This injection mold is opens and closes every so many seconds. Maybe 30, 40 seconds, maybe 1 minute. And after it's open, it will actually open up. This robot arm will have air, suction, come down, pick up the plastic part. They get pushed out. The ejector pins push out the plastic part. The robot arm will come up. It'll come over right here. Then it'll drop the component right on the conveyor belt. And once they drop on the conveyor belt, they're hot. Those plastic pieces are not melting, but they're very hot to the touch, not comfortable to touch. From here, they're going to drop in the basket. The operator will inspect the pieces. If they're good, he'll take and package them. If they're not, maybe he takes the X-Acto knife and cuts them a little bit. His quality control processes stays up here. So those are the instructions for every single part. So when you're taking a look at a factory, you want to make sure that they're following the process. To be ISO certified and compliant is one thing, but to actually have the work orders and pieces traveling with the components is very important to show that you are following those processes and procedures. From here, looks like he packages the parts in the box, and then that box will end up getting packaged, shipped to the customer. In this room, you'll see a series of injection molding presses. Each machine is numbered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you can see that these are smaller machines. So smaller parts, smaller molds, smaller machines. Typically for your smaller production runs, you wouldn't have a robot. You would have an operator in there, and the parts will either be ejected and fall down, or the operator will actually manually put the hand into the mold and pull it out. The plastic pellets are in this right here. They're dropping down. They're slowly going into the barrel. From there, they're going to be pushed through with a screw or a ram. It's being heated up, and that's extremely hot. I can feel it from here. It's being pushed into the injection mold, filling that cavity. It's slowly filling that cavity with that hot liquid plastic. And once it gets to a certain temperature, it will cool down. They're running water through the machine. They're running different materials through the machine to cool the mold down. It will open up. The ejector pins will push out the plastic part. The robot will come down. It will drop the part. And it actually removes the screw into the bucket over there. And then the component falls down the conveyor. And the operator over here is manually fitting it with a type of O-ring, different type of soft material. So it has this is what they're calling the assembly room. So inside this room, you have different operators, different machines, air. That air, they're using an ultrasonic welding machine. Let's go take a look at this. Is sonic welding. So ultrasonic welding is basically using a frequency that will vibrate so fast, 20,000, 40,000 times per second. It'll heat up so fast. The two pieces of plastic actually melt and fuse together, almost like glue, but it's not glue. So they're taking the lid and they're taking the bottom and they're putting the two pieces together manually. It's gonna ultrasonic weld them together at a high frequency. It seems like glue or an adhesive, but it's not. It's extremely difficult to see, but around the perimeter of this component, around this piece is what's called an energy director. Like a small little triangular piece that's going to be friction. It's going to be vibrated so fast that it's going to turn to a glue, but it's basically melted plastic because it's going to be vibrating or moving so quickly. They're using air over here to blow out the clear plastic component and remove any debris. And here, the semi-automatic process where he's putting a steel pin inside the top and the bottom lid. This machine with air will push it to force that pin into place. And here's an arbor press, and they're taking the arbor press with another plastic piece, blowing the air out. Over here, they're using a type of cleaner, maybe it's isopropyl alcohol, and sucking it. Then manually, a human takes and packages those into a packaging box. You are correct. This is finger protection.